So we can write R of x plus S of x is congruent to F of x plus P of x mod H of x. Degree of R of x plus S of x is less than degree of H of x തന്നെയായിരിക്കും കേട്ടോ. Already discuss ചെയ്ത അതേ കാര്യങ്ങൾ തന്നെയാണ്. And similarly, G of x plus P of x ഇതുപോലെ similarly കാണാം. Okay. What is G of x? R of x is congruent to G of x mod H of x. And P of x is S of x set. Okay. So G of x നമുക്ക് എഴുതുമ്പോൾ എങ്ങനെ എഴുതാം? So G of x is written as some Q3 of x. Okay. So Q3 of x into Q3 of x into H of x plus R3 of x and next what? P of x. So P of x is same as P of x is what? Q2 of x into H of x plus S of x. Okay. So G of x plus P of x is equal to Q3 of x plus Q2 of x plus H of x plus some R3 of x. I'm sorry, it's not R3, it's R of x. Okay. So R of x plus S of x. So this is, reminder is R of x plus S of x is the same as F of x plus P of x. Okay. So what? G of x plus P of x is congruent to? G of x plus P of x is congruent to F of x plus P of x. Okay. So similarly, we can prove F of x into P of x is congruent to G of x into P of x mod H of x. You already number theory discuss the same കാര്യങ്ങൾ തന്നെ. So this is a property. Same as we can prove that one. So this is the example. Same as this one. Here. H of x is 1 plus x raised to 5 and F of x is 1 plus x raised to 7 and G of x is 1 plus x square. So here P of x is 1 plus x raised to 6. Okay. So F of x is congruent to G of x mod H of x. Then F of x same lemma same details തന്നെയാണ്. So first we find F of x plus P of x കാണാം. And next G of x plus P of x. So both of them divided by H of x. So we get the remainder. We get a same remainder of these functions. We can say that these two functions are equivalent or they are congruent to mod H. Okay. So product similarly then. So this is the problem. So next section is introduction to cyclic chords. That means what is cyclic? Cyclic chord. We have a C is a chord. Then what is a cyclic chord? We already discussed cyclic means what in general in vector space what is that? It has a generator. So suppose V is the vector space and some element is the generator of suppose in നമ്മളിപ്പോൾ ഡിസ്കസ് ചെയ്യാം ഗ്രൂപ്പിലാണെങ്കിൽ നമ്മൾ ജനറേറ്റർ കേസ് എങ്ങനെയാണ് ഇപ്പോൾ G is a group and if A is the generator of that group G, so what A can be generated the whole element in G. അല്ല നമ്മൾ കൺസിഡർ ചെയ്യുന്നത്. So similar ways അത് തന്നെയാണ്. ഇപ്പോൾ suppose C is a linear chord and V is a chord word in C, then we can be generate the whole elements in C. Okay, so that is the cyclic meaning. So here V is a chord of length n. The cyclic shift. So this is the pi of V. Pi of V means that a cyclic shift pi of V is the word of length n obtained from V by taking the last digit of V and moving it to the beginning. All other digit moving one position to the right. Okay. So that means, so V is the chord. Okay. V is the chord. So V is the chord. So what is V? Suppose we take 1, 1, 0, 1, 0. So this is the V. So pi of V means what? The last digit of V. So last digit is 0. So this is moved into the beginning of the word. That means 1010. This is the last digit. This can be moved into the first one. Beginning kodukka. But this one. So what is the second element? What is the first element is 1. So which moved to the second position? So that means 0. This is the first one and V1 is the second one and 0 move into the next position. That means 0 is here second position. So cyclic shift this 0 into next position, third position and 1 is the last position. So this is the pi of V. Okay, this is the shifting. So shifting means a last digit of the V, it move into the beginning of the word. Then other elements move to the next position to right. Right like or a position at change here. So next one is 1. V is 10110. So what is pi of V? 0 is the last digit, which so taken as first element. 0. 1 is the first element, move into the second position. 0 is the second position, move into the third position. And 1 is similarly. This is the element. 1. So this is the cyclic shift. Okay. And a chord C is said to be cyclic chord. This is the shifting element. Cyclic shifting of a word. And a chord is said to be cyclic chord if the cycle shift of each chord word is also a chord word. So suppose C is a chord word and we take cyclic shifting of every element which is same as the chord word in C. C ilulla adhe elements thanneyaanu namukku kittunnadengil what will say C is the cyclic chord. Okay, so discuss the here example. Here C is equal to what? 0 0 1 1 0 1 0 1 0 1 1 is a linear cyclic chord. And first we take 0 0. V as 0 0. Shifting of 0 0 is same as 0 0. Okay. And the second one is pi of 1 1 0. That means 0 is the last element which take into the first position. So that means 0 1 1. Pi of 1 0 1. 1 is the last digit, move into the first one. So 1 1 0. Clear? Pi of 0 1 is 1 0 1. So again, what is the shifting elements? 0 0 0 1. 0 0 belongs to the set C and 0 0 1 1 which also element in C and 1 1 0 belongs to the set also and 1 0 1 also in C. So therefore this C is called cyclic chord. Okay. And 4.22 discuss here 1 0 0. 1 0 0 shifting element is what? 0 1 0 which is not in C. So this what we'll say C is not a cyclic. So this is the lemma. Pi of V plus W is equal to pi of V plus pi of W and pi of AV is equal to A into pi of V where A belongs to the set K is equal to 0 1. Thus to show that a linear chord C is cyclic, it is enough to show that pi of V belongs to C for each word V in a basis for C. Okay. This is the operation, shifting operation. So pi of V plus W is same as pi of V plus pi of W and also pi of AV is the same as A into pi of V. So that if a linear chord C is said to be cyclic, what that a shifting element of each word is also belongs to the set C. Okay. Same as proof of the same thanyana. V is taken as V1, V0, V1, etc. Vn minus and W is this one. Then V plus W is what? V0 plus W0, V1 plus W1. Okay. And pi of V plus W is, so last element is Vn minus 1, Wn minus 1 which move into the first one. So next other, this is position this one. So same as the NLF. Pi of V plus pi of W. Pi of V പറയുമ്പോൾ എന്തായിരിക്കും? ഇതിനെ നമുക്ക് again split ചെയ്യാം. So here what? Vn minus 1, Wn minus 1. So split into what? split ചെയ്യുമ്പോൾ എന്ത് കിട്ടും? Vn minus 1, Vn minus 1, Vn minus 2, etc. V naught, V1, V naught plus Wn minus 1, Wn minus 2, etc. W1, W naught. This is same as pi of V and this is same as pi of W. Okay, so this is the example. So this is the linear, cyclic linear chord. Okay, so next, construct a cyclic linear chord. Then we can pick up, okay, V form as set S. So S be the set consisting of V and all of its cyclic shift. That means S is the set, is the collection of all V comma, V is a chord word, pi of V is the shifting, and pi square of V means that pi of V. So that means here V is 1 0 1 0 and pi of V is what? 0 1 0 1, and pi square of V means pi of V. That is equal to operations same as. So pi of what? 0 1 0 1. That is equal to what? 1 is the last one. So moving to the first one. 1 0 1 0. Okay. This is the pi square of V. Again pi cube of V what? Pi of pi square of V. Okay. So we can take S is equal to V comma pi of V comma pi square of V, etc. pi n minus 1 of V. And define C to be the linear span of C. So this set span C. C in this span cheyum. So all of its element is what? Is an element in C. Okay. Since S contain a basis for C, C must be a cyclic by lemma 4.2. So C must be like this one. To show that pi of V belongs to C for each word V in a basis for V. That our cyclic process S which is the basis. So here is the problem. Here n is equal to 3 and V is equal to 1 0 0. S is equal to V pi of V pi square of V. Here n is equal to 3 but n minus 1, that is 3 minus 1 is 2. So S is the set V pi of V pi square of V. That is the 1 0 0 0 1 0 0 0 1. That is, this element can span K3 whole set. And W is another element. W is another element in terms of S is the set what? V pi of V pi square of V. So this set spans C means that this is an element. S is the element. So any element in C can be written as the linear combination of the basis element. So W can be written as A naught V plus A1 pi of A1 pi of V plus A2 pi square of V. That means pi of W is equal to A naught pi of V plus A1 pi square of V A2 pi cube. That is equal to A2V plus A2V plus A naught pi of V plus A1 pi square of V. Pi of W means shift order change. So that is the form. Okay. If a word and a cyclic shift form the set S is equal to V comma pi of V comma etc. pi n minus 1 of V, which spans the chord C, then we say that V is the generator of the linear cyclic chord C. Okay. So if taken as V is some chord in C, then S is the set V pi of V pi square of V etc. pi n minus 1 of V, which spans the linear chord C. Then V is said to be the, and then V is called generator of the linear chord C. Okay, so this is the generator and the cyclic chord. So this is the notation. If the word V corresponds to the polynomial V of X, then the cyclic shift of V, pi of V corresponds to the polynomial X V of X, mod 1 plus x raised to n. In general, 1 is congruent to x raised to n mod 1 plus xn. Okay, so here pi of v corresponds to the polynomial. Pi of v the corresponding polynomial is x into v of x, which mod 1 plus x raised to n. So here v is equal to 1, 0, 0 and v of x is 1. 1 x coefficient is 0 and x square coefficient is 0. And pi of v means 0, 1, 0. So corresponding to the polynomial what? X into v of x is x. V of x is 1. So x into v of x is, that is again x and n. Okay. Next, v is 1, 1, 0, 1 and v of x is 1 plus x square. Corresponding polynomial is this one. And shifting of the word is 1, 1, 0, 0. 1, 1, 1, 0. Corresponding to the xvx varum. Xvx means x plus x square plus x cube. Here length is, pi of v is 1, 1, 0, 0. Correspond to the xvx mod 1 plus x raised to. Here 1 plus x raised to n. N is, length is here 4. So 1 plus x raised to 4. N plus x raised to 4 corresponding with the polynomial 1 plus x cube. So next example is v is equal to 1, 1, 0, 1, 0, 0, 0 and n is equal to 7 and v of x is equal to 1 plus x cube. So v is 0. This is not constrained. So here v of x is 1 plus x cube. Then x into v of x is what? X plus x square plus x raised to 4. So this means 1 in the position 0 on x is position 1, x square is 1 and x cube is not here. So the corresponding word is 0 and x raised to 4 is 1. So other two, x raised to 5 and x raised to 6 is 0. Okay. And x square into v of x is what? X square into v of x is x square plus x cube into x raised to 5. Clear ana? X square into v of x is x square plus x cube plus x raised to 5. So that means this one. Okay. So x square. So here 1 and x are not here. So 0, 0. X square is 1. X cube is 1. X raised to 4 is not here. So 0. And x raised to 5 is 1. X raised to 6 is 0. Okay. So similarly we can take this one. And here modulus is, here n is equal to 7. So 1 plus x raised to n ആണ് modulo varundathu. So 1 plus x raised to 7. So here x raised to 4 plus x raised to 5 plus x raised to 7 is this polynomial. X raised to 4 into v of x is divided by 1 plus x raised to 7. We have a reminder. Similarly 1 plus x raised to 4 plus x raised to 5 divided by 1 plus x raised to 7. They have, so that means both of this polynomial divided by 1 plus x raised to 7 have same reminder. Therefore, these two polynomials congruency hold. Similarly, x raised to v of x is x raised to 6 is this one. Okay. Up to if n is equal to 7, n minus 1 ആണ്. So that means x raised to 6 into v of x. Appo 3 cases. Clear ana? Then c of x belongs to v of x. This is the word. Okay. V of x, x square v of x, x into v of x. Okay. So v of x into v of x, etc. x raised to n minus 1 v of x modulo 1 plus x raised to n. Clearly. So this c of x can be written as a naught into v of. So this is a basis element. Okay. So a naught v of x plus a1 x plus v of x plus etc. plus a n minus 1 x raised to n minus 1 v of x modulo 1 plus x raised to n. Okay. So v of x is a common element too. So take it as outside. So we get this polynomial is represented by a of x. a of x, v of x modulo 1 plus x raised to n. So therefore, c of x is the any element in the set this one. So which is what? Which is equal to a of x into v of x modulo 1 plus x raised to n. Okay. So this is the example. And this example is a lemma consider. So the lemma is, let C be a cyclic chord and let V belongs to C. Then for any polynomial a of x, then C of x is equal to a of x into v of x modulo. That is, C of x is congruent to. This is the congruency. So C of x is congruent to a of x into v of x modulo 1 plus x raised to n is a chord word in C. So this is the lemma says. So C is a cyclic chord and V belongs to C. For any polynomial a of x is congruent to C of x. C be a cyclic chord and V belongs to C. For any polynomial a of x, C of x belongs to what? It's the collection of set of v of x, x into v of x, etc. x raised to n minus 1 v of x. Okay. So, for any a of x, C of x is congruent to a of x into v of x modulo 1 plus x raised to n. So, is also, that is this C of x is also a chord word in C. So, that is the lemma C. Okay. Next, we define the generating polynomial. So, what is generating? Suppose C is a chord. We prove a question. Suppose C is a linear chord and V is a chord word in C. So, this is the generator of C in the parayumma consider generator aanengil we can construct a set S. S is what? V, pi of V, pi square of V, etc. pi raised to n minus 1 V of V. So, this set spans the linear chord C. So, then V is the generator of that linear chord. Okay. So, we will level check V in the generator. Okay. And so, this is the generating polynomial. Generating polynomial of a linear chord C to be the unique non-zero polynomial of minimum degree in C. Okay, so this C of x. C of x is uniqueness prove cheyana. Okay, you have to check it this. Same as number theory uniqueness check consider C of x and representations and the quotient same and prove and remainder is also same. So C is the unique linear chord. Okay. We have a theorem. This discuss later. We'll discuss later.